So we're going to look at a few problems here that are all going from moles, or from mass to representative particles. So we're looking for the representative particles, including the type of representative particle in each of the following samples. Okay, so I notice that I'm given mass, and I can always get from mass to moles by using molar mass. Okay, and then I can get from moles from molar mass. All right, I can get from moles to representative particles by using Avogadro's number. Okay. I'm just going to work these out as we go. So I start with 0.120 kilograms of titanium. Okay, I can't use molar mass without starting with mass in grams, so I've got to get that kilogram into grams. So I want kilograms in my denominator and grams on my numerator. I know for every 1 kilogram, kilo means 1,000, so that's 1,000 grams. So my kilograms cancel. Okay. Now I want to get rid of mass and get into moles, and I know that 1 mole of titanium is going to be equal to its molar mass. So I'm going to look on the periodic table, and titanium has a molar mass of 47.87 grams per mole. Okay. So now my grams cancel and I'm in moles, but I want representative particles. So I know I need to get rid of moles, so I'm going to have 1 mole of titanium in my denominator, and my numerator will be Avogadro's number of representative particles. However, since I know my substance, I need to write the correct representative particle. So this is just an element, so the representative particle would be the atom. So now my moles of titanium cancel, and I'm going to be left in atoms of titanium. Okay, to plug this in my calculator, I'm going to take it just step by step. Okay, I'm going to start with 0.120, and I'm going to multiply by 1,000. Get that answer, and divide it by 47.87. Get that answer, and now multiply it by Avogadro's number. So times, and use parentheses for Avogadro's number. Get that answer, and this will be my final solution. So 1.51 times 10 to the 24th atoms of titanium in this many kilograms of the sample. Okay, let me grab a different color marker so it's easier to keep up. If I can figure out how to open these. Okay, we'll use purple. I like purple. Alright, here we're dealing with grams of sodium sulfite. We're already in grams, so I don't need to do this step to get into grams from kilograms. Instead, I can just get straight from grams to moles using the molar mass. So I know that 1 mole of sodium sulfite is going to be a certain number of grams of sodium sulfite. Now, since sodium sulfite is a compound, I'm going to have to calculate the molar mass. All right, but before I do that, I want to go ahead and set up the rest of my problem. Alright, this is going to cancel out my grams, and I'll be left in moles, so I still need to get from moles to representative particles. So I'm going to have 1 mole of sodium sulfite on the bottom. I'm going to have Avogadro's number of particles. However, since we know the identity of our substance, we can go ahead and use the correct number, or the correct type of representative particle. All right, sodium sulfite is a ionic compound. You've got a metal and a polyatomic ion. So we're going to have formula units as our representative particle. All right, here we'll cancel our moles, okay, and then we'll end up with the formula units of sodium sulfite. Okay, before we can do any math, we still need to calculate that molar mass. So I've got sodium, got sulfur, and I've got oxygen. Oxygen has a mass of 16 grams per mole. Sulfur has a mass, if you look on here, it should be like 32.07. Okay, and sodium has a mass of 22.99, and you can see that right here as well. Okay, since we've got 2 sodiums in our formula, I'm going to go ahead and kind of just keep this off to the side like this. All right, 22.99 times 2 should be like 23, so 46, so 45.98. 45.98 grams per mole. All right, for sulfur, we've only got 1. And oxygen, we have 3. So 48. If you add that up, so we're going to get 48 plus 32.07 plus 45.98. You get a molar mass of 126.05 grams per mole, meaning they should have 126.05 grams of sodium sulfite, for every mole of sodium sulfite. Okay, now we can actually do the dimensional analysis. Okay, and so we'll do 2.25 divided by the molar mass. So divided by 126.05, get that answer, and then multiply it by Avogadro's number. So we get 1.07 times 10 to the 22 formula units of sodium sulfite in that mass. Okay. All right, let's do another color for carbon dioxide. So here we've got a mass of carbon dioxide. Okay, I want to get out of grams and into moles. So 1 mole of carbon dioxide is going to weigh a certain number of grams of carbon dioxide, or have a mass of that. This will cancel out my grams, and I need to cancel out moles and get into representative particles. So 1 mole of carbon dioxide is going to have Avogadro's number of representative particles. Okay, carbon dioxide is a covalent compound, so the representative particle is the molecule. So our moles will cancel, and we're going to be left with molecules of carbon dioxide. Okay. Okay, we still need to find the molar mass. Okay, so we've got carbon, we've got oxygen. Oxygen has a mass of 16 grams per mole. We've got 2 of them. This is going to be 32 grams per mole. I didn't give myself enough space, sorry about that. Carbon has a mass of 12.01 grams per mole, and we just got 1 of them. If you add those up, we get a mass of 44.01 grams per mole. So there's 44.01 grams of carbon dioxide. We'll kind of do this for every mole of carbon dioxide. Okay, now we can do the math. So we're going to take the given mass, 52, we're going to divide it by the molar mass, and then we're going to multiply by Avogadro's number. This will give us 7.11 times 10 to the 23 molecules of carbon dioxide.